The Romans and the Vikings are two of the most famous peoples in history, but what were the DNA differences between them? Now, the roots of the Romans were in the Latins and Italic tribe, but their real identity was forged at the crossroads of Etruscan, Greek and Mediterranean influences. The Romans grew from a small city-state into a vast centralized empire, stretching from Britain to the Middle East. The Vikings, by contrast, were not an empire, but a culture. A network of Scandinavian seafarers whose identity was expressed through raiding, trading and exploration, without a unified state or central authority. Now, Roman civilization is generally dated from the founding of the Italian city of Rome in the 8th century BC to the collapse of the Western Roman Empire in the 5th century AD. The Viking Age, on the other hand, is usually dated from the late 8th to the mid-11th century. But what were the main DNA differences between them? Well, the first key difference between the Romans and the Vikings comes from the makeup of their ancient DNA. Now, in general, Europeans, either historical or today, are a mixture of three main sources: hunter-gatherers, early European farmers, and then steppe ancestry. Yet the Romans and the Vikings had different percentages of these three peoples. If you look at these pie charts, you can see how the percentage of early European farmer ancestry was higher in Romans than Vikings. This general pattern is still present in Europe today as well, as early European farmer ancestry is generally higher in southern Europe than northern Europe. Now, the early European farmers were Neolithic populations who introduced agriculture to Europe between around 7000 and 4000 BC, and they were originally from the Anatolian region. So this higher level of early European farmer ancestry in Romans is one difference, and another is actually in the source of their hunter-gatherer ancestry. Although both had this hunter-gatherer component in general in their ancient DNA, the contribution in Romans was mainly from Western hunter-gatherers. The Vikings' hunter-gatherer component, on the other hand, came from a mixture of two main sources, namely Western hunter-gatherers, but also Eastern hunter-gatherers. This group was collectively known as Scandinavian hunter-gatherers. And we know that this Eastern influence brought different allele frequencies into Scandinavia. One key trait, for instance, was genes linked to blonde hair. This was because blonde hair most likely originated around Siberia, with Eastern hunter-gatherers bringing these alleles into Europe, as groups of them moved west across Eurasia. And we can also see another difference in the third ancestral component of the Romans and the Vikings, namely steppe ancestry. As you can see in this breakdown, the Vikings had higher levels of steppe ancestry than the Romans, and this steppe ancestry is associated with the spread of lactase persistence, i.e. the ability to digest milk into adulthood. The Vikings therefore had higher levels of lactose tolerance than the Romans, with environment also another key factor. The northern climates of Scandinavia created a strong selection for milk consumption. Mediterranean populations, on the other hand, relied more on crops and fermented dairy, with weaker selection pressure for lactose tolerance, although milk products were still consumed by the Romans. So although the Romans and the Vikings grew out of the same ancestral pool, these three main sources, they had different levels of these three sources, and this led to different traits evolving in the different peoples. But what were the main DNA differences between the Romans and the Vikings during their high points, namely the Roman Empire and the Viking Age? Well, the good news is there has actually been very good research, academic research into both peoples, so we do have a decent understanding of these peoples, the genetics of these peoples. But before we look at the overall key differences between the two peoples, let's get a breakdown of their genetics individually. Now, a massive academic study from 2019 was published in Science that looked at the genetics of the city of ancient Rome. The study was led by researchers from Stanford University, and they analysed 127 Roman genomes spanning the past 12,000 years. Now, they go through how the ancient ancestry of Romans was basically a mix of these three sources we discussed earlier. And by around 900 BC, roughly when the city of ancient Rome was founded, the authors note that the inhabitants of central Italy had relatively similar genetics to modern Mediterranean populations. Yet during the imperial period in Rome, which the authors date from around 27 BC to 300 AD, there was a major shift in the DNA of ancient Romans. This was a shift in ancestry towards the Eastern Mediterranean and the Near East, with very few individuals of primarily Western European ancestry at this time. Imperial Romans' principal component analysis largely overlapped with modern peoples from the Near East and Eastern Mediterranean, such as the Greeks, Maltese, Cypriots, and Syrians. The study notes that this shift in ancestry broadly follows the empire's expanse across the entire Mediterranean. Rome at this point in general was very much a melting pot, reflecting gene flow from across the Mediterranean and North Africa. Yet what is interesting is the lack of Western European ancestry that came into Rome during this period. This was despite a vast network of Western European trading routes from the Western Mediterranean, but we don't see gene flow from the Western Mediterranean into Rome during this period, the imperial phase, which is quite interesting and somewhat surprising. This of course suggests relatively limited immigration from the Western provinces. The author suggests one reason for this is due to the higher population density that was in the Eastern Mediterranean versus the West. Yet regardless of the reasons, this shift in ancestry doesn't remain that long. The average ancestry of ancient Romans during the late antiquity period changes, which the study dates from around 300 to 700 AD. At this point, Roman DNA shifts away from the Near East and towards modern Central European populations. Now there are various reasons for this. One is due to reduced contacts with the Eastern Mediterranean in general. Another factor, of course, came from campaigns of Germanic peoples such as the Visigoths, the Vandals and the Lombards. Now this trend towards Central and Northern European ancestry continues into the medieval and early modern periods, and you can see how ancient Roman DNA changed through the different ages in this breakdown from the study. And you can see that by the medieval and early modern periods, there was essentially a complete loss of this Near Eastern and Eastern Mediterranean clusters. But what were the main haplogroups amongst Imperial Romans? Well, look at this spreadsheet. So this is the breakdown of the 127 Roman genomes from the study, tracing about 12,000 years or so, which is really interesting. And I know this might look a lot, but in this column basically you've got the date of the sample. In this column you've got the archaeological period, as the study defines it anyway. And you can see the gender in there of the samples, and then the mitochondrial DNA haplogroups, and then the Y DNA in this column here. So yeah, this traces 12,000 years all the way through the imperial period and right down to actually the Renaissance as well. And this is just the supplementary information of the study if you want to look at it in more detail. But yeah, the very earliest samples we can see are typical Western hunter-gatherers. This is a male, the earliest one in the study, belonged to the mitochondrial DNA haplogroup U5, which is very common, a branch of that. On the Y DNA side, the branch of I, which again is very common. I2A was a very common Y DNA haplogroup among Western hunter-gatherers. But yeah, it's the imperial period that we're after in this one. So there's about 40 samples or so from the imperial period, and we get a really good breakdown of the mitochondrial Y DNA haplogroups from a proper academic source as well, which is always good. So the first sample in the early part of the imperial period, you can see the date here, so about 22 to 120 AD basically. Female, and she belonged to U1A1, which I did actually pull up the family tree DNA breakdown of this one as well. So an old kind of broad haplogroup, but branches of U are obviously very common amongst Europeans in general. And you can see the breakdown today from the family tree database at least. Quite common in Sweden and Italy and Turkey, but still quite common in Italy today, which is quite interesting. But yeah, if we go back to the breakdown, you can see the mitochondrial haplogroups from the imperial period. So like I say, there's about 40 people or so from the imperial period in this source. And if we scroll down a wee bit, you can see U is very common, branches of U, J, H, T, branches of T. You can see a branch of K in there as well, another branch of K, branches of T. So quite common haplogroups, quite standard for Europe. There is also unusual ones as well. This one, for instance, D4J11, which is one I hadn't really heard of before, and mitochondrial haplogroup D is quite unusual, or quite rare at least in Europe. So again, I pulled up a family tree DNA breakdown of this one, and you can see some of the dates involved, but you can also see it is, it does appear within the samples from Italy and also from Sicily within the database for family tree DNA at least. So still somewhat common in Italy, or found in Italy at least, as well as Hungary and Russia. But it's quite interesting, this one, not one you would typically associate or initially jump to. But yeah, you can see it's still in Italy and Sicily and some people still today. So if we continue down here, like I say, you can see branches of K, branches of H, branches of U are all very common. And this is the last one from the Imperial period, late Antiquity period. Again, a female and belonged to a branch of U6. And yeah, if we now look at the Y DNA side as well, we scroll back up. So this is again the earliest period from Imperial Roman period, but the first male sample belongs to a branch of R1b, so RPF 7589. And again, I pulled up the family tree DNA breakdown for this one. Again, quite a broad category, but you can see in the population today from the family tree DNA database, at least, the United States, Germany, England, people from those countries have this sort of haplogroup, and you can obviously dig into more detail if you want. But yeah, branches of R1b were somewhat common amongst Imperial Romans, but you can see the second male here actually belongs to EV12. This is a branch of E1B1B, and you'll know obviously this is quite common in North Africa, or very common in North Africa today, somewhat common in Southern Europe in general, but this probably reflects North African ancestry to some degree as well, which is interesting. Now, if we scroll down, we can see branches of Gi become very common. Gi2a was a very common, probably the most common Y-DNA haplogroup amongst Imperial Romans, Imperial Roman men, obviously. You can also see a branch of G. G2a was another common Y-DNA haplogroup amongst the Romans. And you can see in particular this branch of Gi, Gi-L26 was quite common, probably the most common one from these imperial samples. And again, I pulled up the kind of breakdown of this one. Again, it's quite a broad overarching haplogroup, but you can see the breakdown here, and you can also see the frequency descendants in these following countries. So in Saudi Arabia, in Italy, and the United States today, relatively common. And I don't know, it might be the Italian ancestry in the United States that means this is quite high, obviously, as well. But you can see this is still common in Italy today. And this was probably the most common lineage amongst Imperial Romans. But certainly Gi2a, branches of Gi2a, was the most common Y-DNA lineage. And this does connect to the Eastern Mediterranean and the Near East as well. And we'll look at a map just in a second of Gi2a today, and you can still see that that's reflected. But yeah, Gi very common amongst Imperial Roman males. And let me just scroll down here to the bottom. You can see, yeah, branches of G, occasional branch of T in there. But you can see Gi and G very common. And just to kind of complete this, you can move right down. This is the Renaissance period, but you can see still Gi and G were common. You can see R, you can see E, and you can see quite a common continuation of these broad haplogroups. So like I say, this is in the supplementary information of the study, and it's table 2, if you want to really get into the detail and really look at it in detail. But I just wanted to give you a broad overview of the actual academic research, because I know there's lots of stuff people say online, but it's good this actually looked at Imperial Roman DNA from, proper academics from Stanford to get a good breakdown of them. And let me know if you share any of these lineages or the exact kind of subclad as well. That'd be interesting in the comments below. Now, overall, Roman Y-DNA haplogroups were dominated by branches of Gi2, especially Gi2a. If you look at this map, you can see that Gi2 is high in the Eastern Mediterranean and parts of the Near East still today. Other notable haplogroups were branches of G2a, branches of R1b, with subclans like R1b, U152 later becoming common in parts of Italy, as well as some E1B1B lineages, which largely reflected North African ancestry. As we've seen as well, mitochondrial haplogroups were dominated by branches of H and U, as well as others like Gi, T and K, with some more rare haplogroups like D and X in certain cases. But what about Viking DNA? Well, Scandinavians during the Viking Age displayed a genetic profile that reflected both local continuity and extensive contact with the wider world. Viking DNA reveals that while their core genetic makeup was distinctively Northern European, it also varied depending on the region of Scandinavia. Genetic studies of Viking burials show that people from Norway, Sweden and Denmark were not identical. Instead, they carried slightly different genetic signatures that largely reflected the directions of their overseas activity. I did make a member on the video on the DNA differences between Vikings, where I go into more detail. I will put a link below if you're interested, and if you're enjoying this video, please consider subscribing. Now, Viking Y-DNA haplogroups were dominated by I1, the quintessential Scandinavian lineage. Other common Y-DNA haplogroups were R1b U106, strongly tied to northern Germanic populations around the North Sea, and common in Danish Vikings in particular, given their proximity to Germany. Another was R1a Z284. The most common mitochondrial haplogroups amongst the Vikings were H, U, K, T, J and V, all typical of European populations. Now look at this table. This shows the main differences between Roman and Viking DNA. You can see that the Romans' foundational DNA had higher levels of early European farmer ancestry, and it showed more diversity during the imperial period than the Vikings. As we went through, this is because Rome's population at the time of the empire had shifted so heavily towards the eastern Mediterranean and the Near East. Yet later migrations from northern and central Europe reintroduced continental European DNA into Italy in higher numbers. Now you can also see the differences in haplogroups, in appearance and in lactose tolerance as well. From a cultural identity perspective also, an interesting feature of the Romans is that they allowed non-Romans to become citizens, with this policy evolving over time. Although some people did adopt the Viking culture who weren't Scandinavian, most Vikings were Scandinavian of course. Now I should note that there was some indirect contact between the Vikings and Italy in general. Although Vikings themselves never really settled Italy in large numbers, Norse-descended groups did reach parts of southern Italy through the Normans, who of course were largely descendants of Vikings who had settled in Normandy and France. In the 11th century, Normans conquered Sicily and southern Italy, establishing the Kingdom of Sicily. So the story of the Romans and the Vikings is a fascinating one, and they are two of my favourite peoples in history. Although it's not surprising that there were DNA differences, the reason as to why and how reveals more than you would originally think. And please let me know in the comments below if you think you have Roman or Viking ancestry and why you think that. But speaking of your ancestry, what does your ancestry say about your eye colour? Well, to find out, please click here. Thanks for watching, please subscribe and hit the bell, and let me know your thoughts in the comments below, and I'll see you next time.